Organizing data. Topics covers various methods for displaying and analyzing data, including notation techniques and graphical representations such as stem and leaf displays, dot plots, and histograms. It also addresses the handling of qualitative data and the analysis of multivariate data, emphasizing the importance of these tools in interpreting and presenting data effectively. In statistics, the notation nk generally represents the number of observations or elements in the k subgroup or category within a dataset. The sample size, which denotes the number of observations in a single sample, is commonly denoted by n. For example, for a sample of universities such as University of Sharjah, University of Dubai, Ashman University, n equals 3, and for a sample of pH measurements, 6.3, 6.2, 6.5, n equals 3. When dealing with two samples simultaneously, the sizes can be denoted by m and n or n1 and n2. In a data set with n observations of a variable x, the individual observations are represented as x1, x2, x3, xn. The subscript does not indicate the size or magnitude of the observations. Hence, x1 is not necessarily the smallest and xn is not typically the largest observation. A stem and leaf plot is a graphical tool in descriptive statistics for organizing and displaying numerical data. It divides each data point into two parts: the stem, which includes all digits except the last one, and the leaf, which is the final digit. The stems are arranged in a vertical column, with the corresponding leaves listed horizontally to the right of each stem. In a stem and leaf plot for a data set of exam scores ranging from 0 to 100, each score is divided into a stem and a leaf. For example, a score of 83 would have a stem of 8 and a leaf of 3. The stems are arranged in increasing order, and listing the data from least to greatest ensures that every data element is included accurately in the plot. To create an informative visual representation of a numerical data set x1, x2, x3, xn, where each data point she has at least two digits, one effective method is to use a stem and leaf display. This technique organizes the data by splitting each value into a stem and leaf, making it easier to interpret the distribution and characteristics of the data set. A stem and leaf display offers valuable insights into the data by revealing the typical or representative value, illustrating how the data spreads around this value, identifying any gaps, assessing the symmetry of the distribution, showing the number and location of peaks, and highlighting any outliers. To construct a stem and leaf plot for the average points scored by 10 volleyball players, 5.4, 5.8, 8.2, 9.4, 9.5, 9.7, 9.7, 11.0, 11.1, and 12.0, organize the data with stems as 5, 8, 9, 11, and 12, and list the corresponding leaves for each stem. Stems, the left column represents the tens place of each score. Leaves, the right column shows the units place of each score. A dot plot is a straightforward graphical tool used to visualize the distribution of small to moderate-sized datasets. It represents each data point as a dot positioned above a corresponding value on a number line. When multiple data points have the same value, the dots stack vertically, allowing for an easy assessment of the frequency of each value. A dot plot is an effective way to summarize numerical data, especially when the dataset is small or has few distinct values. In a dot plot, each observation is represented by a dot placed above the corresponding point on a horizontal scale. If a value appears multiple times, dots are stacked vertically to represent each occurrence. A dot plot visually represents the frequency of numerical data using a number line, where each dot signifies one student who received the rating indicated by the dot's position above the number line. The table displays the frequency of high temperatures recorded over a recent period. Construct a dot plot to represent this data set. The score of 85 is represented by 4 dots stacked vertically, indicating that 4 students scored 85. The score of 88 is represented by 3 dots, showing that 3 students scored 88. The score of 90 is represented by 2 dots. The score of 92 is represented by 1 dot. In this dot plot, each dot represents a single test score. The number of dots above each score shows the frequency of that score. For example, the score 85 appears 3 times, so there are 3 dots above 85. A histogram is a graphical tool used to represent the distribution of numerical data, similar to a bar graph. Unlike a bar graph where each bar represents a distinct category, in a histogram, each bar displays a range of values, with the width of the bar corresponding to the interval of these values. The height of each bar indicates the number of data values that fall within that specific range, providing insight into the frequency of data within each interval. A numerical variable is discrete if its values are finite or can be listed in an infinite sequence, such as 0, 1, 2, 3, and so on. In contrast, a numerical variable is continuous if its values form a continuous interval on the number line, resulting from measurements and capable of taking any value within a range. For example, discrete variables result from counting and include specific values like 0, 1, or 2, whereas continuous variables, such as pH levels, can assume any value within a range, such as between 0 and 14, including precise values like 7.0 or 7.032. A histogram for continuous data is a graphical representation used to illustrate the distribution of data that can assume any value within a specified range, such as measuring the heights of individuals, which can vary continuously between values like 150 centimeters and 200 centimeters. Unlike histograms for discrete data, which use distinct bars, histograms for continuous data display distributions with contiguous bars, reflecting the continuous nature of the variable being measured. A histogram for discrete data visually represents the distribution of data that can only assume specific, distinct values by using separate bars for each unique value. For example, it can display the frequency of each grade received by students on a test, where grades like 50, 60, 70, and 80 are distinct and individual bars are used to show how many students achieved each grade. This type of histogram highlights the distribution of counts across distinct categories. A relative frequency histogram is a type of histogram that shows the proportion of data points within each bin or interval rather than the absolute number of data points. For example, if 20 out of 100 students scored between 80-90 on a test, the relative frequency for this score range would be 20 divided by 100, which equals 0.2 or 20%. This type of histogram helps to understand the distribution of data in terms of percentages rather than raw counts. To create a histogram, plot the data intervals on the x-axis and their frequencies on the y-axis, with bars representing the frequency of data points within each interval. The table presents a frequency distribution of the number of hits recorded by each team during 9-inning baseball games played between 1989 and 1993. It details the number of games corresponding to various hit totals, illustrating the distribution of performance levels among teams over that period. The histogram depicted in the figure shows a smooth rise to a single peak followed by a decline. It exhibits a slight positive skew, as it extends further to the right towards larger values compared to the left. Based on either the tabulated information or the histogram, we can deduce the proportion of games with at most 2 hits. Approximately 64% of these games had between 5 and 10 hits. Qualitative data encompasses non-numerical information that describes characteristics or qualities, often categorized by names, labels, or types rather than measurable quantities. This data is usually observed rather than measured and includes examples such as the colors of cars in a parking lot, customer feedback on a product, example, satisfied, unsatisfied, and types of cuisine in a restaurant, example, Italian, Chinese, Indian. Multivariate data involves more than 2 variables being measured on the same set of subjects or entities. It is used to understand relationships among multiple variables simultaneously, which can provide a more comprehensive understanding of the data. For instance, in a health study, researchers might examine variables such as age, weight, and blood pressure to uncover health patterns, while weather data analysis could involve temperature, humidity, and wind speed to forecast weather conditions. Thank you for watching.